Welcome to solverfy.
Okay, we've got to consider the monochlorination of the following compounds when heated with Cl2 and include stereochemistry at any stereogenic centers. So let's look at the monochlorination of A. Now remember, selectivity matters here, and that there is a preference for tertiary over secondary over primary radical chlorinations, but there's also a statistical factor, right? That is, if, say, I had a molecule with two equivalent sites, right, these are both secondary, right? It's more likely that I'll end up chlorinating at one of those two secondary sites than this one single secondary site. Right, so I have two equivalent, they're both secondary sites that are chemically equivalent. And so there's two of those, but there's one chemically unique secondary center here. And so we're going to have a 2/3 chance. They're equally likely to be chlorinated based on them being secondary, right? But since there's two of these, that's going to happen 2/3 of the time. And since there's only one of these, this is going to happen 1/3 of the time. And since based on their degree of substitution, their equivalent, then the selectivity will be for the site which there are more of, which is one of these two sites. Okay, so that's great. Now we just need to draw the monochlorination product, which would be as simple as adding a chlorine there. But note, there's a hydrogen here, and we would have created a stereocenter, right? This carbon has 1, 2, 3, 4 unique substituents. So in fact, what we would need to draw is one enantiomer, in which we have a wedged chlorine, and the other enantiomer, in which we have a dashed chlorine. That would be the two preferential monochlorination products of that compound. Okay, now let's look at this methyl cyclopropane. Remember, again, there's a preference for tertiary over secondary over primary. Okay, we've only got one tertiary site, so that's where we should expect chlorination. Okay, and we should put a chlorine there, and there's still a methyl there. Is this a stereocenter? Do we need to show stereochemistry? No, right? Because remember, this side of the ring and this side of the ring are equivalent. You could also say there's a mirror plane of symmetry through the molecule. The point is that there's not 4 unique substituents at that carbon, so there is no stereocenter created. Okay, now let's look at C. Okay, again, preference for tertiary over secondary over primary. There is a single tertiary center, and that's where we should expect chlorination to happen. Have we created a stereocenter? And note, I'm using a script L here, just so we can differentiate it from uppercase I's. Right? I'll always draw script L's or uppercase I's, so they're easily differentiable. So chlorine becomes C script L. Okay, this is the only tertiary center. That's where we're going to chlorinate. But have we created a stereocenter? I would argue no. And that's because at this carbon, we have an ethyl group sticking off, another ethyl group sticking off, and a third ethyl group sticking off. We need 4 unique substituents to create a stereocenter, and that's just not going to happen here, right? There aren't 4 unique substituents. There's 3 of the same, in fact. Okay, finally, we have a hydrogen coming towards us in carbon 2, a chlorine going away from us. And what is our monochlorination product going to be here? Is there going to be a preference for attacking at carbon 2 or at 3? Okay. And here we're looking at the stability then of an intermediate radical like this, or an intermediate radical like this. Which of them is preferable? Right? Well, are radicals electron deficient, or are they electron? They have too few electrons or too many electrons. They're somewhere in between. Nevertheless, a nearby chlorine is actually going to ultimately, there's a preference for the chlorine adding not to the carbon which contains chlorine. That is, this is the more stable intermediate, which means we should expect attack only at C3 in this case. Okay, so for that reason then, recall that this is a planar radical intermediate, meaning we can get attack from the top face or the bottom face, and we get two possible products. That is, we get chlorine on the bottom on carbon 2 and chlorine on the bottom on carbon 3, as well as chlorine on the bottom on carbon 2 and chlorine on top on carbon 3. Right, so these are the two products that will form.